Welcome to Chapter 3. In this chapter, we are learning about data and information mining. This is a very important chapter because the data is the raw material and the information is the processed product. If we know how to harness it properly, data will help us make more accurate and efficient decisions. In this chapter, we will study 3.1 Concepts and Roles of Digital Data and Information. 3.2 Data Organization and Management. 3.3 Effective Information Utilization. 3.4 Evaluating and Verifying Data Sources. 3.5 Data Management and Preprocessing. 3.6 Data Analysis. 3.7 Practice in Data and Information Utilization. In this section, you will learn about the concept and role of digital data and digital information. We'll differentiate between data and information and understand why it's called the new oil of the digital age. Digital data refers to all information that is encoded and stored in the form of zeros and ones. It may be structured, such as Excel spreadsheets or databases, unstructured, such as TikTok videos or Facebook posts, or semi-structured, such as JSON files used by applications. Digital information is data that has been processed and given meaning within a specific context. For example, examination scores are discrete numbers, data. But when the average score is calculated for evaluation, it becomes information. In short, data is the raw material while information is the final product. The difference between data and information. Imagine this: a list of marks such as 5, 6, 7, and 8 is merely raw data. It does not tell us much on its own. However, if we calculate the average score as 6.5 and compare it with the assessment standard, we now obtain information: the class is performing at a fairly good level. This demonstrates that only when data is processed does it become meaningful information that supports decision-making. In the context of the digital economy, data has become a strategic asset. Businesses analyze sales data to identify which products sell best and when peak periods occur. Governments analyze population data to formulate effective policies. As a result, digital data and information have become the foundation for socio-economic development. We can analyze several roles of digital data and information, such as supporting business decision-making. Businesses often rely on data to make informed decisions. For example, analyzing sales data by region helps identify which products are preferred in central versus southern areas. This allows them to adjust business strategies, launch new products, or organize promotions at the right time. Optimizing processes. Collecting data on production or operations helps companies detect bottlenecks and waste. For instance, a logistics company analyzing delivery data might discover that route frequently experiences delays due to traffic congestion, prompting them to adjust the route to reduce costs and improve efficiency. Understanding customers. Customer data is gold. By analyzing purchasing behavior and preferences, businesses can personalize their services. For example, platforms like Shopee or Tiki recommend products that match individual needs, significantly boosting sales. This demonstrates how leveraging data enhances customer experience. In economics, data helps analyze market trends, customer behavior, and operational performance. As a result, managers can make accurate and timely decisions. At the same time, data also creates opportunities for new product development, process automation, and cost optimization. In education, analyzing learning data can help personalize the pathway for each student. For example, based on grades and academic history, the system can suggest appropriate subjects. In scientific research, big data helps researchers find new laws faster. In addition, data analysis also helps universities evaluate the quality of training and improve programs through analysis and evaluation of output standards. In healthcare, data is the foundation for AI to assist doctors in diagnosing diseases. For example, AI analyzes X-ray images to detect early signs of disease. In addition, personalized medicine relies on each patient's genetic data to recommend individual treatment regimens. At the community scale, health data helps monitor epidemics and make prevention policies. When it comes to data mining, we must adhere to ethical principles. Transparency. tells users what the data is used for. Consent permission is required. Minimization, collect only the necessary data. Security, protects data from leaks. This is the responsibility of every individual and organization. Under the European General Data Protection Regulation, GDPR, law, users have the right to know how their personal data is being processed, the right to access, rectify, erase, and the right to complain if it is misused. This is a very important legal framework that many countries are referring to protect the privacy of their citizens. Agencies and businesses, when handling personal data, must respect privacy, provide transparent information, protect data, and report any leakage within 72 hours. This helps build trust and protect users from the risks of data misuse. Therefore, we must be socially responsible when exploiting data. Do not use data to harm disadvantaged groups, spread fake news, or manipulate public opinion. At the same time, digital equity must be promoted so that everyone has the opportunity to access technology and information. This is critical for data to truly serve the community.